Jensen Huang, the visionary CEO of Nvidia, dropped a bombshell at Hong Kong University of Science and Technology. He unveiled some mind-blowing insights about the future of humanoid robotics that could completely change how we think about automation. Jensen revealed that there are 3 types of robots that could be scaled to massive volumes. But what are these robots? And could this mean we're on the verge of a revolution in mass production of humanoid robots? Stick around, because this interview is nothing short of groundbreaking.
There are 3 types of robots that can be manufactured in high volume, and pretty much only 3. Well, the 3 are cars, and the second, drones, but the highest volume...
But why just 3 types of robots fit into Jensen's vision for scalability? And why is scaling to high volume such a game changer? Let's dive in to uncover the answers.
All of the other types of robots that we've seen historically, robotics has been around for a long time, but it's very hard to scale into high volume. Scaling into high volume is important because you need the technology flywheel. The high volume allows you to generate high R&D, which allows you to make great technology breakthroughs, which makes better products, which causes the volume to be even higher. And so that flywheel, that R&D flywheel, is vital to any industry. There are only 3 robots you could really do this for, but 2 of them are going to be the highest volume. And the reason for that is these 3 robots can all be deployed into the world as it is today.
Now that Jensen has explained his idea of scaling robots to extremely high volumes and identified the 3 categories, here's the big question. Why these categories specifically? Why cars, drones, and humanoid robots? The reasoning might seem simple at first, but it's bound to leave you surprised.
Well, the 3 are cars, because we created the world for cars over the course of the last 150 years. And the second, drones, because, the sky is fairly unlimited. But the highest volume one, of course, is humanoid robots. And it's because we created the world for ourselves. And with these 3 types of robots, we can pretty much scale robotics into extremely high volume, and that's one of the advantages that a manufacturing ecosystem like this one, really has.
Humanoid robots being the largest volume, even more than drones? That's hard to picture, isn't it? Imagine a world filled with humanoid robots outnumbering drones. How would such a future reshape society and industries? But as exciting as this sounds, humanoid robots still have a long way to go before they match the success of generative AI in the digital space. And Jensen knows this. In fact, he sheds light on this challenge in a way that makes you realize how close humanoid robotics might be to becoming a part of our reality. The question is, what's holding them back?
What is missing, of course, for robotics is an AI that understands the physical world. ChatGPT, or large language models today, understands the cognitive knowledge and intelligence, but it doesn't understand physical intelligence. It doesn't understand necessarily that when I set the cup down, that it's not going to go through that table. And so we need to teach an AI how to understand physical intelligence.
Jensen believes the missing piece is physical intelligence. But he doesn't just stop there. He explains how this will unlock the next frontier in robotics.
In fact, that we're making good progress. Well, one of the demonstration that all of you have probably seen is you could generate, using generative AI, text to video. And I can surely generate a video that starts out with a picture of myself, and you prompt Jensen, pick up the coffee cup and take a sip. Well, if I can prompt the AI to go and pick up the coffee cup, why can't I then generate the tokens to cause a robotic arm to go pick it up? And so the gap, the leap from where we are with generative AI and general robotics is very, very close.
There you have it. The leap from generative AI to advanced humanoid robotics is closer than we think. That's not just speculation. It's straight from Nvidia's Jensen Huang, a man at the cutting edge of technology. So, what's your take on this bold vision? Could humanoid robots truly scale to mass production soon? Let us know your thoughts in the comments below, and let's get the conversation started. When it comes to humanoid robots, Jensen Huang is no stranger to making bold and eye-opening statements. He's been clear that Nvidia has the technology, combining advanced computing power with cutting-edge generative AI, to make humanoid robotics a reality. And according to him, the time is now. At a recent AI summit in Japan, he made this vision even clearer.
This is the reason why we think that now we have the necessary technology between Omniverse and all the computers that we built, these 3 computers, and the latest generative AI technology, that the time has come for humanoid robotics.
Jensen has repeatedly emphasized the need to teach AI physical intelligence before robots can be effectively deployed in the real world. This isn't just an abstract concept. It's a critical challenge in robotics today.
Now, why is humanoid robotics so hard? Well, obviously, the software developed for human robots is extremely hard. However, the benefit is incredible.
As you just heard, the software behind humanoid robotics is incredibly complex. But Jensen remains optimistic, as he explains. And according to Jensen, we'll see its revolutionary impact firsthand through self-driving cars, drones, and humanoid robots, the latter 2 being at the forefront. As AI progresses, the need to scale these robots into high volumes becomes inevitable. Now here's something that might blow your mind. Elon Musk, Tesla's visionary CEO, has also jumped into the conversation. Musk predicts that by 2040, just 16 years from now, there could be 10 billion humanoid robots in the world.
But I think that's, once you get out 2040, that's a long time from now. Going 25 years, there'll be at least 10 billion humanoid robots.
And price point?
Yeah, the price point will be, I think, quite low. Probably $25,000 for a robot that can do anything.
10 billion. That's not just a prediction. It's a glimpse into a world where humanoid robots become as ubiquitous as smartphones are today. Musk even speculates that Tesla's valuation could soar to $25 trillion as this unfolds. If that doesn't convince you that AI's time has come, I don't know what will. But let's face it, it's not all sunshine and smooth sailing. Scaling to 10 billion humanoid robots is no small feat. To make this future a reality, we need robots that are not just intelligent but physically capable of navigating and interacting with the real world. And here lies the challenge. Creating robots that can simulate human-like physical tasks is significantly harder than building cognitive capabilities. Generative AI tools like ChatGPT are already excelling at cognitive tasks, holding conversations, identifying objects, even recognizing faces. But when it comes to executing physical tasks, something as simple as placing a cup on a table, humanoid robots still have a long way to go. As Jensen explains, the real hurdle is teaching AI physical intelligence.
What is missing, of course, for robotics is an AI that understands the physical world. ChatGPT or large language models today understands the cognitive knowledge and intelligence, but it doesn't understand physical intelligence. It doesn't understand necessarily that when I set the cup down, that it's not going to go through that table. And so we need to teach an AI how to understand physical intelligence.
Understanding physical intelligence is the missing piece in the humanoid robotics puzzle. It's what will determine whether these robots can transition from experimental prototypes to fully functional members of society. And while the road ahead is challenging, the progress being made by leaders like Nvidia suggests we're closer to this reality than ever before. So, what makes these 3 categories, self-driving cars, drones, and humanoid robots, so crucial? And how do they differ from other applications of AI? Let's break it down in a way that'll make it clear. First up, self-driving cars. Unlike other robots, cars operate in structured environments that follow very clear rules and patterns. Think about it. Roads, traffic lights, lanes, speed limits, all the predictable stuff we've come to rely on. This makes cars a perfect fit for large-scale AI deployment. They don't need to navigate unpredictable spaces the way some robots do. Everything is mapped out, which gives them a solid foundation for autonomous technology to thrive. Then we have drones. These little guys started off mainly used for photography and delivering packages, but have evolved. Drones have become critical tools in industries like agriculture, disaster relief, and surveillance. They've gone from a fun gadget to real-world problem solvers. With real-time decision-making and edge computing, drones can now operate independently in complex, ever-changing environments. They can fly over a field, analyze crop health instantly, or help locate missing people in a search and rescue mission. Drones have become so versatile that they're now used in industries across the board. It's safe to say that we're only scratching the surface of what drones can do, especially with an AI platform like Nvidia Jetson. So here's a thought for you. Do you think the number of drones will skyrocket as they get more advanced? I mean, they're already pretty essential in various fields, but could we see them in even more places as time goes on? Drop your thoughts in the comments. We'd love to hear what you think. Now let's dive into the robot category with the most potential for scaling. Humanoid robots. These machines are the absolute pinnacle of AI innovation, and for a good reason. They combine cognitive intelligence with physical capabilities, making them uniquely suited for tasks that require human-like interaction and adaptability. Think about it. Robots that can actually move like humans, think like humans, and interact in ways that feel human. Unlike cars and drones, humanoid robots face a much more daunting challenge. It's not just about processing information, like recognizing patterns or navigating a road. Humanoid robots need to master both cognitive and physical intelligence. Simple tasks that we take for granted, like walking, picking up an object, or even opening a door, require sophisticated AI algorithms and mechanical precision. This isn't your average robot stuff. It's the next level. So, how's Nvidia tackling this challenge? Enter Nvidia's Isaac Sim. This platform allows developers to simulate real-world environments in a virtual space, letting them train humanoid robots before they're deployed out in the physical world. It's like giving these robots a virtual playground where they can learn how to navigate complex situations, test their moves, and adapt to unpredictable environments without any risk of failure in the real world. This simulation is crucial for getting humanoid robots ready for the big stage, our everyday world.
At the conference for robotics learning, we announced a new framework that is super important. It's called Isaac Lab. Isaac Lab is a reinforcement learning virtual simulation system that allows you to teach humanoid robots how to be humanoid robots. And on top of it, we have several workflows that we have created.
But as with anything revolutionary, scaling these technologies isn't a walk in the park. For humanoid robots, the biggest hurdle is physical intelligence. Sure, we've seen massive strides in cognitive AI. Systems like ChatGPT can understand language, recognize patterns, and hold meaningful conversations. But translating that kind of intelligence into physical actions? That's a whole different ballgame. Jensen Huang, Nvidia's CEO, has been pretty vocal about how tough this is, reiterating his comments on this issue. It's not easy to create robots that can interact with their environment in a way that feels natural, like humans do. Teaching a robot to recognize an apple? No problem. Teaching it to pick up the apple without squashing it or dropping it? Now that's a whole new level of complexity. Achieving that level of precision requires breakthroughs not only in AI algorithms, but also in robotics engineering. When we look at it all, Jensen Huang's vision for scaling AI through self-driving cars, drones, and humanoid robots is a bold step into the future. Sure, the road ahead is filled with challenges. There's a lot of work to be done. But the potential rewards? They're too significant to ignore.